Hey guys, Mr. Milton here. Today we're looking at areas of triangles and parallelograms notes. At the end of this lesson, you should be able to find the areas of triangles and parallelograms. Okay, so we'll get a couple of formulas here that you should be pretty familiar with, but I want to make sure that we use them correctly and clarify some common mistakes before we start. Okay, so area of a parallelogram, that's just base times height. And this is something that you probably already knew, so hopefully I'm not telling you anything different from that. Okay, but like I said, we've got to clarify some common mistakes here. The base of a parallelogram can be either side. Okay, it doesn't have to be the one on the bottom per se. It can be either side, but each side has a corresponding altitude. And when we're talking about height, that is what we're talking about. We're talking about a perpendicular distance from one side to its opposite side, and that's what we're talking about, height. Okay. In this triangle below, the length of the altitude, is what we call the height. Okay, length of the altitude is height. In this parallelogram, which length could represent the base? Okay, so as we look at this parallelogram, remember we said either side of the parallelogram we could call the base. So either 2 or 2.5. Okay, either one really doesn't matter. Well, I say that it kind of does. Which one makes sense to use in this problem? Well, we could, like I said, either one of these is the base, but it only makes sense to use 2.5 in this problem. And the reason we would want to use 2.5 in this problem is because we're given the corresponding altitude of 1.8 meters. Okay, that corresponds with the 2.5. That corresponds with the 2.5 meter base. Okay, and we know that because of the right angle symbol. Okay, that's how we can tell that is the altitude. Okay, and so we can find the area of this parallelogram by just doing 2.5 times 1.8. And so that just gives us 4.5. And so we want to say 4.5 meters squared. Remember, this is a unit. Meter squared is a unit, so please don't square 4.5. Okay, it's a unit of measurement. All right, what is the altitude associated with the other base? Now you might be like, well, we don't know, they didn't tell us. True, but since we know the area, we do have a way to find out what the altitude of the other base would be, okay? And so even though they didn't give us this, we know that the area of a parallelogram is base times height. In this case, we know what the other base could have been, right? We used 2.5 as the base here, but now we could say, well, our area, since we know it's 4.5, it equals our base, which is 2, times our other height. So 4.5 divided by 2 should give us the other height, and that height would be 2.25. Meters, I guess. Okay, does that make sense, hopefully? All right, so here it says find the area of each parallelogram below. All right, number 1. Again, we're given 2 side lengths or bases, but it's up to us to choose which one makes sense to use. Here, we're given 3.5. Notice that is the perpendicular distance from one base to the other base. Even though it's outside of the triangle, it's still the perpendicular distance from one base to its opposite side. So to find the area of this parallelogram, I'm going to use 2 times 3.5, which just gives me 7 centimeters squared. Number 2, they tell us that FC is 10. Okay, we're given DE, which is 12, and AD, which is 13. Okay, it's up to us to decide which one of these is bases. Now, we're only given one base, and that's DA, 13. Okay, so area equals base times height. We're only given one base, 13. So we really need to pick the height that corresponds with its base. Okay, so DA, CB, we need to find the distance between these two bases. That distance is 10. Okay, it's perpendicular to this side. You'll notice that this side continues out here. They can draw this anywhere. They just decided to draw it outside, right? If they did it in here, it would just look like a more busy picture. So make sure that you guys don't get confused about something being written outside of the shape, okay? So area, 130 inches squared. Okay, numero 3. All right, start with a little bit of fun here. So here, number 3, they gave us 2 bases. They gave us 8 and 12. And so they really don't give us the height, but they did give us enough information to find the height, okay? As you look and you say, well, they gave us this angle 60. What are we supposed to do with that? Well, we can boom, make a 30, 60, 90 triangle here, right? Make a right angle, 30, 60, 90. And so because we just did 30, 60, 90 triangles, we know our hypotenuse is 2x, our short leg is x, and our long leg is x radical 3. The measurement that we're most interested in, though, is this altitude, this x radical 3, right? Altitude, right angle. Okay, and so since we know that 2x is 8, we know that x is 4, we know our height is 4 radical 3. It corresponds with our base 12. So the area is base times its corresponding height, and that is 48 radical 3. And I'll say meters squared. Okay. All right. And number 4, being a parallelogram, they give us this angle is 135 degrees. You kind of know that we want to see this 90-degree angle, right? Okay. Now, the hard part is that, like, wait a sec, we don't know any of the angles here then, because we have to split this 135. We don't know the other one. But it is a parallelogram, right? And so remember that we know this about parallelograms is that the consecutive sides are supplementary. So if this is 35, that must mean that this angle is 45. 45, 45, 90. Special right triangle. Crazy. All right. And then we know in this 45, 45, 90, our opposite sides in a parallelogram are congruent. Okay, so we had to use a little bit of what we knew about parallelograms from our quadrilateral chapter, and now we'll use a little bit of what we know about 45, 45, 90 triangles just from earlier in this chapter. Okay, so if this is 4, then we can say, okay, this is x radical 2 is 4. This is x and this is x. The height that we care about here is x, but they're the same. So we can say 4 equals x radical 2. Let's find out what x is. Okay, and so we need to rationalize this denominator because we cannot have a radical in the denominator in our final term. And so we get 4 radical 2 over 2, which gives 2 radical 2. Okay, so x is 2 radical 2. Okay, so now our base is 8, and its corresponding height is 2 radical 2. So 16 radical 2. And they didn't give us a unit of measurement, so I'm just going to say unit squared. Okay, so there we have it. Area of parallelograms, base times height, making sure that you're using the height and not 2 bases. Okay, all right. Here we go. So it's area of a triangle. We should know this. We've been using this for a while. 1/2 base times height. Okay, why the 1/2? Every triangle is half of a parallelogram. Parallelogram. Right, we could split any of these parallelograms into a triangle. Whether it's a square or a rhombus or just a parallelogram, we could split it into a triangle with just a line. Okay. Okay, so just like in a parallelogram, the base can be any side of the triangle, and the height or altitude must be perpendicular to the base. Perpendicular. Okay. Or perpendicular to the base. Okay, so here as we look at this triangle, let's find the area of each triangle. Notice what altitude we're given. We're given the altitude 5. Our base here's 14. Like I said, we can think of this as like half of a parallelogram because we'd make it a parallelogram just like here, right? So we're not going to do that, but that's why it's 1/2 base times height. All right, so our base in this case, we'll choose the one that's perpendicular to the altitude that we're given. So area equals 1/2 base 14 times the height 7, or 5, sorry. So 1/2 times 14 is 7, 7 times 5 is 35. So the area of this triangle is 35 units squared. Okay. Number 2. Here we go. Number 2, they're asking us for the area of this triangle. Notice here that we have a couple different numbers on the outside. Probably want to identify what they are. But we're only given one side of the triangle, and that's this one is 10. Okay. Area is 1/2 base times height. Okay. So now as we're looking at this, a height that corresponds with this base, and we kind of have it already, right? The 6 feet here, perpendicular distance, all right? So that is our height that corresponds with it. What is this 3? Okay, the best I can tell you is if you don't know what the number means, please don't just try to plug it into the problem. Okay, the 3 is just there. It just tells us the distance. I don't know. I mean, there's not really an application for us here. Okay, so our base is 10. Our height is 6. 1/2 base times height. So 5 times 6 is 30. All right, so our area is 30 feet squared. Last example here, it says the wall of a garage shown below can withstand 7,500 pounds of force. How would the wind, or how fast would the wind have to travel to knock down the wall to the nearest unit? Okay. So force is 0.004 AB squared. So force, area, volume. Okay, gotcha. So as we're looking at this, we need to find the area. All right, so as we look at this, they tell us the force can withstand 7,500. That is our force. They give us this formula and tell them what everything is. 0.004. And then we have area, which we need to find in order to plug into our formula. The area here, base times height. And in this case, they don't really tell us this is perpendicular. I don't want to say that it is. All right. So that gives me 120, 240. Okay. And then this base is 20 and the height is 6. So 120 divided by 260. So the area of this figure is 300. All right. And then the velocity, we don't know what that's going to be because that's the question. It says how fast. All right. So let's solve it for 7,500 divided by 0.004. It's a big number. Divided by 300. Okay. So I'm just dividing both sides by this. So we can get v squared by itself. So we get 6,250 equals v squared. To find v, we need to take the square root of that. And that is 79.05. So 79 miles per hour. All right. There we go. That's areas of triangles and parallelograms. That should be it. See it.